Okay, so there are three main parts of the unit circle. There are the angle measures in degrees, the angle measures in radians, and then the coordinates. So typically the unit circle is actually drawn on a coordinate plane. All right. Now, we're going to start with doing the angle measures first. And you technically have already seen these before because we did this when we were learning how to convert between radians and degrees. So you guys remember on the radians foldable, how it had that circle with all the angle measures and degrees on it? That actually was the unit circle, just an incomplete version of it. So we're going to first start with the easiest of the three, which is the angle measures in degrees. Now, the way the unit circle works is, let's say these are axes, which they technically are, the x and y axis. You always start at the right side of the x-axis and you go counterclockwise. So as we're going around counterclockwise. Now, the best way to do the degrees is to think about it in terms of a fraction. So if you don't have a calculator, you may want to grab one. So the main thing is that we're going to be doing fractions of 180 degrees. So in reference to 180. So obviously, if we haven't started anything yet, this is 0 degrees. Okay, we haven't moved anything yet. Now, if you notice, if I just look at this semicircle, what fraction type is it in? So if you just look at what the highlight section is, what's the fraction type? Well, the semicircle's half, but like what's it broken apart into? It's broken apart in fourths. So that means if I'm 1/4 away from 180, what's a fourth of 180? So in your calculator, do 1/4 times 180. See what you get. 45 degrees. If I do another fourth of 180, what do you think it would be? So in other words, it would be 2/4 of 180. 90. Or half 180. If I do another fourth, so this would be 3/4. What's 3/4 of 180? Again, you got a calculator, just do 3/4 times 180. 135. And then 4/4 of 180 would be 180. So that's the first half. Do you guys notice a pattern? What's it going up by? It's going up by 45. So we're adding 45 between each fourth. And that's the pattern for the fourths. So if we follow that same pattern, so starting with 180 and we keep going, what do you think this one would be? It'd be what? Not 45. Add 45 to 180. 225. If I add another 45, what would that be? 270. If I add another 45, what would that be? 315. And then the last 45 would be 360. So that's the pattern for the fourths. You're just going up by 45. So this first circle references the fourths. And again, by fourths, I mean in terms of 180. So that's why I only highlight the top part, because when we're talking about fourths, we're talking about in terms of 180. If you want to do it in terms of a whole circle, it'd be eighths. But you'll see why I'm saying fourths when we get to radians. It makes way more sense when we do the radians. That's why it's called fourths. Okay? Now, That's the first part. The second part is the sixth. So if you look here, we got the same axes. All right, we're still going to be referencing just the semicircle. So in terms of 180, still starting at the far right horizontal line. So this will be 0 degrees. And we're going around counterclockwise. So semicircle is 180 degrees. So what is a sixth of 180 degrees? 30. I add another 6, so it's 2 6. What's 2 sixths of 180? 60. I add another 6. What's 3 sixths of 180? 90. That's half. I add another 6. What's 4 sixths? 120. Or also 2/3 if you want to think about it that way. I add another 6. What's 5 sixths? 150. And then 6 sixths would be 180. So just from doing that path, what's the pattern? You're adding 30. So I'm adding 30 between each sixth. So if I follow that pattern, what's the next one? 210, then 240, then 270, then 330. Then finally 360. So you always want to end up where you left off because that's a full rotation around the circle. And again, the pattern is you're just adding 30 for each one. So those are the two main parts. Again, this was the sixth. And again, it's in terms of 180. So if you really want to think about it in terms of 360, it's 12ths. But again, trust me, the sixth makes sense when you get to radians. Now, we're then going to take these two circles and overlap them. Okay? So that gives us the unit circle. So you got to think this pretty logically. All right. You still start over at this end. So this will be 0 degrees. Now, the first line, think about this logically. Which is smaller, a 6 or a 4th? A 6. So what would be my first number? 30. Now, the next one, would this be a 4th or would this be 2 6 or a 3rd? Which is smaller, 2 6 or a 4th? You sure? A 4th. If you simplify 2 6, it's 1/3. That's definitely bigger than a 4th. So this would be 45 degrees. Now, we know we're not going to get another 4th until we get to the top here. So this has to be another 6. So what's this? 60. So essentially, if you combine these two circles, you're going in numerical order. So the next one would be 90. The next one would be, the next one would be 135. The next one would be, next one would be someone else. 180. Then, what's the next one between those two circles numerically? 210. Then 225. Then 240. Then, and then finally, good. So that is all of the angle measures of the unit circle in degrees. And if you look, so these are always used as reference. But if you want to know where your fourths are here. So there's your fourths. And then also on these two lines, obviously. Your sixths are here. All right, so knowing where those are really, really will help you. Now, does anyone see a pattern of the angle measures? Like anything that we can add? There actually is a pattern. So how do I get from 0 to 30? Add 30. How do I get from 30 to 45? Add 15. How do I get from 45 to 60? Add 15. How do I get from 60 to 90? Add 30. How do I get from 90 to 120? 30. How do I get from 120 to 135? Add 15. This will also be add 15 and then add 30. So the pattern, if you're one of those people that memorize things through patterns, the pattern is 30, 15, 15, 30, repeat. And that's what you add. So add 30, 15, 15, 30, repeat. 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. Like in that order. So that's why I say repeat. So like after this last 30, it doesn't pick up at 15 again. It goes back to 30. So that's the pattern for the degrees. That's what you add. Does that help a little bit? You were to memorize that? All right. Turn to the back side. So that's the degrees. Let's do the radians. So let's do the radians. Now, same process. We're going to be doing it in fourths and sixths, just like we did the angle measures. And to be honest, the fourths and the sixths, actually, you'll see it better with the radians, why we do fourths and sixths. You'll see why in a second. So, firstly, start here at 0. Not 0 degrees, just 0. 0 radians. Just like with the semicircle, we're still doing things in terms of the semicircle, so we're doing fourths of the semicircle. Now, here's my question. A full rotation of a circle in radians is what? Nope. In radians, what is a full rotation of a circle equivalent to? How many radians? 2 pi. So, you're going to end with 2 pi. So that means halfway around would be what? Just pi. So the equivalent of 180 is pi. All right. So now we're doing fourths of pi. So if we're doing the first fourth away from 0, what's a fourth of pi? What is it? Pi over 4. We add another fourth. So it'd be 2 pi over 4, but what does that simplify down to? Not pi over 2. Oh, no, it is pi over 2. I'm sorry. It's pi over 2. Okay, we add another fourth. So add a fourth to 2 pi over 4. What is that? 3 pi over, not 3, but 4. Pi would be the same thing as 4 pi over 4. It just simplifies down to pi. Okay, still adding fourths. So if I add another fourth, what would this one be? 5 pi over 4. We're just adding another pi or another 1 to 4 pi. If I add another fourth, what would it be? 6 pi over 4. But what does that simplify down to? 3 pi over 2. The reason I'm making you simplify is because on the unit circle, you have to use the simplified versions. I'm just showing you where you can get the numbers from. All right, add another pi, or add another fourth. 7 pi over 4. And then if I add another fourth, this would be 8 pi over 4. Sorry. Which is 2 pi. So that is the fourths. So that is the fourths in radians. And the ones you need to know are these. So the simplified versions are the ones you need to know. Those are the ones you need to know. But if the, the unsimplified version helps you, just know you got to simplify it. Yeah. I'm just saying that, like, say you were, like, doing it and you were like, crap, what's a fourth after 3 pi over 4? Or, no, like 5 pi over 4. Okay, it's 6 pi over 4, so that simplifies down to 3 pi over 2. All right. Same thing, but now we're going to do the 6. So, again, still starting with 0. We're going to end with 2 pi. And then pi will be over here. And again, we're doing it based off of a semicircle. So the 6 is a 6 of a semicircle. So it's all going to be in terms of pi. So what's a 6 of pi? Pi over 6. If I add another 6, what would the next one be? 2 pi over 6, which simplifies down to what? Pi over 3. They can both be divided by 2. That gives you pi over 3. All right. If I add another 6, what is it? 3 pi over 6, which simplifies down to what? Pi over 2. If I add another 6, what is that? 4 pi over 6, which simplifies down to 2 pi over 3. All right. If I add another 6, what is it? 5 pi over 6. If I add another 6, that would give me 6 pi over 6, which is still just pi. If I add another 6, what would that be? 7 pi over 6. If I add another 6, what would that be? Someone different. 8 pi over 6. And what does that simplify down to? 4 pi over 3, yes. All right. Add another 6. What would that be? 9 pi over 6, which simplifies down to what? 3 pi over 2. I add another 6. What would that be? 10 pi over 6, which simplifies down to what? 5 pi over 3. Add another 6, that'll be what? 11 pi over 6, that doesn't simplify. And then finally, if I add another 6, that'll give me 12 pi over 6, which simplifies to 2 pi. So do you see why I said doing the fourths and the sixths kind of matter? Yeah, it really helps with the radians. So again, the ones you need to know are the green. So these values are the ones you need to know. Now, where students struggle is putting them together, so overlapping those two circles. But it's just a matter of thinking, okay, which fraction is bigger? Or which fraction is smaller? So, look at the denominator specifically. So we're going to start here with 0. Think about it in terms of a 6, a fourth, a third, and a half. Which is the smallest out of those 4 options? A 6 is the smallest. Okay, so what do you think is going to come first? Pi over 6. So that leaves us with a fourth, a third, and a half. Which one's smaller now? A fourth. So that's pi over 4. Third and a half. Which one's the smallest? So which is smaller, a third or a half? A third is. So pi over 3, and that leaves us with a half pi over 2. Now, we know it's going to be another 6 from pi over 2. So pi over 2 is 3 pi over 6. So what would come next? It'd be 2 pi over 3. Good. Then we'd have the fourth, which is 3 pi over 4. Then we have the 6, which is, yep. Then what? Pi. So then this would be the next one. That's not 6 pi over 4. Nope. 7 pi over 6. Think about in terms of like when you get to a half, think about what's farthest away. A 6, a half, or a fourth, or the closest to it. A 6 is the closest. So you're going to do a 6 next. Whether that be over 6 or over 3, depending on where it is. Okay. What's next? So what is it? 5 pi over 4. Then 4 pi over 3. Then 3 pi over 2. Then 5 pi over 3. Then 7 pi over 4. Then 11 pi over 6. And then finally 2 pi. Now, you're probably thinking, oh crap, this is a lot to remember. Okay, so here's how I learned it in high school, because my high school teacher did not break this down for me. They just handed me a sheet of paper and said, memorize it. Okay, so literally, I learned tricks to memorize this. So, how I learned to memorize it is you really just need to memorize that first quadrant, specifically their denominators. Okay? If you notice, there's a pretty clear pattern with what the denominators look like. So if you look, it's 6, 4, 3, 2, and then it goes back down. 3, 4, 6, pi. Okay? So the denominators, if you want to think about this way, will be 6, 4th, 3rd, half, and then it goes back down. 3rd, 4th, 6th. And then it just keeps flip-flopping. Okay? So then you get to like the 0, which is the pi, and then you do it again. 6, 4th, 3rd, half, 3rd, 4th, 6th, 0. Does that make sense? Now, the numerators, so this whole first quadrant, the numerator is always going to be pi, nothing else. So for the first quadrant, the numerator is equal to pi. Now, look at the second quadrant. Here's my question. Look at the denominators versus the numerators. What's something that you can clearly see? So look at the numbers in the numerator versus the numbers in the denominator. What do you see? The numerator is 1 less than the denominator. That's how I learned it. So in the second quadrant, the numerator is 1 less. So if you add 1 to the numerator, that gives you the denominator. Or let's put it this way. The numerator is equal to the denominator minus 1. And then obviously with a pi. Okay? So, because you know the pattern of the denominator is going to stay the same. So if you know that this one's 3, well, 1 less than 3 is 2, so 2 pi. If you know this one's 4, 1 less than 4 is 3 pi. If you know the next one's 6, 1 less than 6 is 5 pi. See how it's going? They're always going to have pi in them. Just get that in your head now. They're always going to have pi in them. If they don't, you're wrong. The only one that doesn't is the 0. That's it. The third quadrant. Look at the numerators versus the denominators. It's 1 more. So the numerator is equal to the denominator plus 1. So we know the numerators are going to be some form of 6, 4, and 3. So if you add 1 to each of those, that'll be 7, 5, 4. Now, the last one is a little bit weird, but it's not bad. Okay? So the last one, I don't expect you to see it. But if we're still following the numerator-denominator relation, how it relates is the numerator is equal to twice the denominator minus 1. So think about it. What's 3 times 2? Minus 1. 5 pi over 3. What's 4 times 2?
8.
Minus 1.
7.
7 pi over 4. What's 6 times 2?
12.
Minus 1.
11.
11 pi over 6. Of course, you can still do it as a, you can still do it in terms of the fractions itself if you want to go that route. But if you're someone like me that needs like little tricks and patterns to help you memorize something, there's your trick. Okay? That's how you remember it. That's how you can remember it. You don't have to remember it like that, but that's just little tricks that can help you. And just remember, with radians, they're always going to have a pi in the numerator. No, it's 3. It's 3.
Oh my god.
This is the first 3
Okay, so that's the easy parts. Now we got to talk about how you get the coordinates. So for that, you need to go to your packets. So take out your packet, and we're going to go to page... I would still keep that paper out because you may need to reference it, but we're going to go to page 5. No, it's page 5. Oh, I used a different one. It's page 9. I have a different PDF in here, but it's the same paper, just different order that was in. All right. So we already talked about the angle measures, both radians and degrees. Now we got to talk about the coordinates. And to do that, we actually got to think about some triangle stuff and some circle stuff. So this is a little bit of a review from Unit 6 in this class and from Math 2. Okay? So the basis of trigonometry is formed by the unit circle. And it's simply a circle that has a center located at the origin, so 0, 0, and has a radius equal to 1 unit. Hence why it's called the unit circle. The radius is 1. So it's 1 unit. So its radius is a unit. So think about this carefully. Which equation represents the equation of the unit circle? So to recall, Formula for equation of the circle is x minus h squared plus y minus k squared is equal to r squared, where your center is equal to hk and your radius is equal to r. So what do they say my center is at for the unit circle? The center is where? At the origin, so that's the point 0, 0. What's the radius? What's 1? They told us the radius is 1. So you can just plug that into here. So I have x minus 0 squared plus y minus 0 squared is equal to 1 squared. What's x minus 0? X, so that's x squared, plus what's y minus 0? Y, so that's y squared. What's 1 squared? 1. So that's the equation of the unit circle. That's review from unit 6. Remember, we did a whole unit on circle equations. Now, the next part, we got to do some stuff with special right triangles. So the unit circle's actually built up of special right triangles. All right. So we're going to, so we got to review special right triangle stuff. So we're going to consider the right triangle shown whose hypotenuse is equal to 1 and the angles are both equal to 45 degrees. It's an isosceles right triangle, meaning that two sides are equal and they're labeled as x. So we're going to use Pythagorean theorem to solve for x. And we're going to leave our answer in simplest radical form. So recall, Pythagorean theorem is a squared plus b squared is equal to c squared. So how would I set this up using the values that are here on this triangle? X squared plus x squared is equal to 1 squared. Now, aren't these like terms? X squared and x squared? So I can make it into what? If I combine like terms, x squared plus x squared is 2x squared is equal to 1 squared is 1. So before I can take a square root, I got to do what first? Divide by 2. This will be x squared is equal to 1/2. And then I'm going to square root both sides. Now, just for review, and again, I'm not going to require you guys to do this. I'm just showing you where these numbers are coming from. Because these numbers are actually what's going to go on your unit circle that we're coming up with. And you'll see why in a minute. But we can separate this square roots into two little square roots. So I have the square root of 1 over the square root of 2. What's the square root of 1? 1. And we don't know what the square root of 2 is. Now, in Math 2, you learned about something you may not remember, and that's okay, something called rationalizing the denominator. It's basically a fancy way of saying we don't like square roots in the denominator, so we have to multiply the top and the bottom by said square roots that's in the denominator. So I'm going to multiply the top and the bottom by the square root of 2 over the square root of 2. So, what's 1 times the square root of 2? Square root of 2. What's square root of 2 times the square root of 2? Square root of 4. You just multiply the two numbers underneath. So finally, we keep square root of 2 on top. And what's the square root of 4? 2. So x is equal to the square root of 2 over 2. So this would be the square root of 2 over 2. This would be the square root of 2 over 2. Now, I'm not making you guys do this just for funsies. We're actually going to be, you'll see these numbers again. So if there's like, I'm just saying, I'm not making you guys just do it just because, okay? These numbers will actually be seen again. So, we're going to consider the 30, 60, 90 right triangle whose hypotenuse is equal to 1. Why do you think they're picking 1? How does that connect to the unit circle? Why do you think they're picking 1 for the hypotenuse? The radius is 1. So in this case, essentially what we're doing, the 1 is representing the radius. The hypotenuse for both triangles represent the radius. Okay? So, clearly this triangle is half of an equilateral triangle. So they want to know what is the length of the shorter side. First off, which one would be the shorter side? The one that's across from the 30 or the one across from the 60? Well, think about it logically. Do you think a smaller angle is going to create a bigger side than a bigger angle? No. So the short leg is here. This is the long leg. Now, they said that this triangle is half. That's terrible. They said that this triangle is half of an equilateral triangle. Because remember, equilateral triangles, all of the sides are congruent. All the angles add up to 60. So that's why this one would be 30, because 30 plus 30 is 60, and this one's still 60. And all 3 sides are congruent. So that means that this side would be what in the equilateral triangle? So like if I just look at this triangle right here, the whole red triangle, it's an equilateral triangle, meaning all sides are congruent. So what's the length of this side? 1. Now, they said that this triangle, or the one that we're actually using, if you want to highlight, that's good too. So this is a triangle we're actually using. But they said that this is half of an equilateral. So what would this side length be if we took half of an equilateral? 1/2. So this side length would be 1/2. So the shorter side length is 1/2. Now we're going to use the Pythagorean theorem to find the other side, or the long leg. So I'm going to call this x. So how do I set up Pythagorean theorem for this question? So again, we're using the yellow triangle. What's the Pythagorean theorem for this? So it's 1/2 squared plus x squared is equal to 1 squared. What's 1/2 squared? You can put that in your calculator. And I want it as a fraction. So what's 1/2 squared? 1/4. So I have 1/4 plus x squared is equal to 1. How do I solve for x squared? What do I do next? How do I get the x squared by itself? Subtract the 1/4. So x squared is equal to, what's 1 minus 1/4? 1.5. Well, no, not 1.5. No. 1 minus 1/4. 0.75, which is 3/4. Yeah. You want to leave it in fractions for this little piece. You were correct. I just wanted it as a fraction. So I'm going to take the square root of both sides. That goes away. Ladies, shh. Now, we're going to do the same thing that we did with the previous triangle and break apart into 2 different square roots, which you can do. All right. If you have something over something under a square root, you can break it apart into 2 mini square roots. So we can't do the square root of 3, but what's the square root of 4? 2. Since there's no radical in the denominator, we're done. So x is equal to the square root of 3 over 2. So that's the square root of 3 over 2. All right, now, here is why we did that effort. Like, why the heck we even bothered. So here's my question. We dealt with a triangle that's 45, 45, 90. We dealt with a triangle that was a 30, 60, 90. How does those angle measures connect to the unit circle? They're what? Right. So if we did the unit circle in degrees, I'm only going to do degrees. Are you looking for this?
Mrs. Davis said that she might be here.
I think she went downstairs real quick. She went somewhere. The computer's still here. So I'm just going to label the angle measures real quick. At least in degrees for right now. Ladies. All right. So again, 30, 60, 90, 45, 45, 90. Where do you recognize those angle measures from? Look at the first quadrant specifically. That's degrees that pop up there. And we said that each of these radii are what? Because all of these lines right here are radii. Because they come from the center to the edge of the circle. So all of those lines right here are equal to what? What's the length of the radii in the unit circle? Nope. What's the length of the radius in the unit circle? 1. They already told us that. It's up here. The diameter, but we don't really need to worry about that. So, in my hand, I have a right triangle. I am going to line it up as best as I can with the unit circle. Let's see. I want the hypotenuse, so right here, to line up with one of the radii in the first quadrant. So, oh, would you looky there.
Wait, so wouldn't that be equal to 90? Because it's a right triangle.
That's a 45, 45, 90 right triangle, because what's this angle measure? 45. What's this angle measure? 45. There's the 90. Well, we already said that this radius is 1. So what are these two measures? We literally just did it.
1.
Square root 2 over 2 for both. Now, where is that coming to play with the coordinates? Okay. So where is that coming to play? Think about it. What's true about the two legs of the triangle? They are what type of lines? One is blank, the other one's blank. Horizontal and vertical. Horizontal and vertical can be turned into what in terms of a graph? X and Y. So we have the length horizontally and the length vertically. So in other words, for 45 degrees, if I was to write this as a point from right here, what would be the x value? The x-axis is always what? So the x-axis on a graph is what? It's horizontal. So I'm going to use the horizontal line. So what is it? Square root 2 over 2. What would the y value be? Square root 2 over 2. And just like that, you found one of the coordinates on the unit circle. So, just to recap, right here is our 45, 45, 90 triangle. We found the radii to be 1, and this is 45 degrees, 45, 90. And when we did the Pythagorean theorem earlier, this was the square root of 2 over 2. This was the square root of 2 over 2. So that means the point is the square root of 2 over 2, square root of 2 over 2. Because if you think about it, x values are horizontal, y values are vertical. So we base it off of these values. Now, that's a 45, 45, 90. But that won't work for these other two angles. But what triangle will? What triangle that we already did would work? 30, 60, 90. So I'm going to move this bad boy over here. And I got here a 30, 60, 90 triangle. Now I'm going to line this up with the 30 first. The hypotenuse is still the radius. So probably going to have to turn it this way. And bada bing, bada boom. So this is the 30 degrees. This is the 60 degrees. And here's the 90 degrees. So if this is 30 degrees, that means the short leg is here or here. Is it the vertical or the horizontal? It's vertical. Because if you think about it, this is the angle, that angle's at 30 degrees. Okay? So what's the short leg? What do we find the short leg to be in length? 1/2. This is the long leg. What do we find the long leg to be? Square root 3 over 2. So what do you think, following the same pattern that we did for 45 degrees, what do you think the point would be at 30 degrees? So the x value is horizontal, the y value is vertical. So what would the point be? Yep. Square root 3 over 2 and 1/2. So if I look back at this triangle, here is my 30, 60, 90, where this angle is 30. That's not dark enough. Where this angle is 30 degrees. This angle is 60 degrees. 90. So this is the short leg at 1/2. This is the long leg at square root of 3 over 2. Horizontal, vertical, the point is square root of 3 over 2, 1/2. Then, using that same triangle, we're going to manipulate it to work for the 60-degree angle. So I'm just going to flip it over. So now, this angle is the 60 degrees, and this angle is 30 degrees. So is my short leg the horizontal or the vertical line? It's horizontal. By the way, these triangles are drawn to scale, so you can kind of eyeball them. Okay? So, this is horizontal, which we know the short leg to be 1/2. Long leg is square root 3 over 3. 2. Square root 3 over 2. So, what would my point be for at 60 degrees? 1/2, because that's my horizontal, and square root 3 over 2. And guess what? You pretty much got the basis of the points down. Because all that's going to happen is that these exact points, these 3 points, are going to repeat. You just change the signs of it, whatever the quadrant is. All right? So, we'll come back to these 4 corner points. Yeah, the cardinal direction points. We'll come back to that in a second. But let's look at 120. Which of my 2 triangles, or 3 triangles in this case, So which of my three triangles, if I line these up, crap. Okay, so if I line these up, which of these three would fit in the 120? Would it be the 30-degree angle one, the 45, or the 60? The 60. So guess what? The point is going to match what the 60 is. So 1/2 square root 3 over 2. Because the triangle is just going to be a reflection of its former triangle. So on your paper here is my 30, 60, 90 triangle, where this is 60 degrees, 30 degrees. So that is 1/2. That is square root 3 over 2. That's 1. So this point is 1/2 square root 3 over 2. Now, if we were looking at this from a graph standpoint, what quadrant is this? Where these three triangles are? What quadrant? 1. This is quadrant 1. What's true about the points in quadrant 1? They're both what? Positive. So we just said that if we were to draw the triangle here at 120, it would be the 60-degree one. So it would match this triangle over here that's yellow. So that means the point is just going to repeat. So it'll be 1/2 square root 3 over 2 in some shape or form, but we're not done yet. Because what quadrant is this where the 120 is located? It's quadrant 2. What's true about the points in quadrant 2? It's a negative and then positive. So the x's are negative. So what do you think I'm going to have to do to this point? Make the x negative. That's what I mean by change the signs to fit the quadrant. All right, so that means here, this x becomes negative. All right, now look at the 135. Which of these three triangles, the 60, the 45, or the 30, would fit for the 135? The 45. So if I drew this one works with the 45 degree. So that means it's going to have the same point as the 45 degree, except what happens? What's the only change to that point? The x becomes negative. That's the only thing that changes. What about the last one, this quadrant, the 150? So this is negative square root 2 over 2, square root 2 over 2. Okay. Last one, this quadrant. Which triangle would fit? The 60, the 45, or the 30? The 30. It's just a reflection. So that means it's going to share the points of the 30. So square root 3 over 2, 1/2, except what? The x is negative. So again, this is the 30. And all that happens is the same point, but the x value is negative. Now, we're gonna come back to 180 in a second, but going into the next quadrant, what quadrant is this? 3. What's true about the points in quadrant 3? They're negative, negative. So that means both of the signs from the points in quadrant 1 are now going to change to negative. No, that's 3. It goes around in a circle. So it's 1, 2, 3, 4. So Which triangle do you think would fit here? The 30, the 45, or the 60? The 30. So it's going to line up with the 30. So what do you think the point's going to be, including the sign changes? Right. Negative square root 3 over 2, negative 1/2. So that's what this point is.
We're trying to unfreeze her screen. She left. Not sure how. No, it's not working.
It's okay, Mr. If you're watching, guys.
Do you need it to be unfrozen right now? See if you guys can figure out the rest of the points for your unit for quadrant 3.
Exactly. Oh my gosh.
Okay. So, the 225, which triangle would you have? Nope. 45. If you notice, there's a pattern. So, this is the 45. So, if I change the point to fit the quadrants for the 45 point, what is it? Uh-huh. Yep. It's still negative because it's negative, negative.
And you know what? You said it was 60.
All right, so this would be negative square root 2 over 2, negative square root 2 over 2. Whoever's doing that, please stop. All right, what about the last one for quadrant 3? 60. So that would be the yellow triangle. So what's the points? Good. So negative 1/2, negative square root 3 over 2. Okay. Last quadrant. So this is quadrant 4. Aiden, you're new at the office.
Oh, thank God. Bye. It's like
All right, so shh, 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 shh. So this is quadrant 4. What's true about the points in quadrant 4? Positive, negative. So that means the y value is going to become negative. So the first triangle at 300, so right here, which one does it match up with, the 30, 60, or the 45? The 60. So if we're matching up with the point, what's the point? 1/2 negative square root 3 over 2. Good. This would be 1/2 negative square root 3 over 2. What about this next one? So, what about this one? Right. It's a 45. So it'll be square root 2 over 2, negative square root 2 over 2. That's what goes here. And the last one will have to be a what? So we did a 60, a 45, so it has to be a 30. So what's the last point? So what is it? Good. Now, there are still 4 points that we have not derived yet, but honestly, these are the easiest ones. So I want you guys to think about this logically. What's this point in the center of the circle? Where's the center of the unit circle at? What point? 0, 0. What's the radius? 1. What point is 1 away from the origin to the right on the x-axis? So it's 1 away from 0, and it's on the x-axis. 1, 0. It's an x-intercept of 1. So this would be 1, 0. What about vertically? So what's 1 away from on the x-axis on the y-axis? 0, 1. It's a y-intercept. What about to the left of 0? Negative 1, 0. It's back on the x-axis, but it's in the negatives now because it's to the left. What about on the bottom of the y-axis? 1 away. 0, negative 1. That's why I saved those 4 for last, because they're really easy. So this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So essentially, guys, we have finished deriving the unit circle. So now let's put it all together.
It's not done?
No, it's done. We're just going to put it all together. So the radians, the degrees, and the points. That's the 3 parts of it. And that's all you got to memorize. So put your package to the side for right now. We'll come back to it in a second, but go to that copy of the unit circle. So the way that I fill in a unit circle, I do 1 piece at a time. Okay? And by the way, I will be, from here on until your test, every day, your exit ticket is going to be a unit circle test, a unit circle quiz, and I want to time it.
Starting tomorrow?
Starting tomorrow. So, but here's the deal. Basically, I will take your highest score. So if you get 100 on the first time, it's completely from memory, and I'm timing it. I'm probably going to give you like 5 minutes tops. Okay? Because you got to know it. I can do it in 2 minutes, just saying. If you want to time me, you can later. Anyway. So, but each day I'm going to get a little bit faster. All right? So we're going to start with 5 minutes.
10, maybe 10.
No, not 10. 10's too much. No.
7.
Anyway, so I want to time you each day. And again, I'm going to grade them every day. If you got 100 on it at some point, you don't have to take it anymore. Okay?
What?
But if you don't get 100, you have to take it again and go for a higher score. So I'm going to take your highest score after the end of all the unit circle quizzes. Well, it's a solid 60 points grade.
Oh.
So it's a point per piece. So
Wait, so in order to stop doing it, you have to get 100?
in order to not have to take it the next day, you have to get 100. Yeah. It's pretty much just doing all of this and plus the radians. So the radians isn't on here yet. But like what we did earlier in class.
So you're
Is it different one each time, or is it the same thing?
It's going to be the same thing over and over. There's no other unit circle. This is the unit circle.
Worst memory ever.
But here's my trick. Here's the thing, guys. So here's the thing. The best way to memorize this is to write it over and over and over again. And I literally printed off over 100 unit circles. So I don't mind if you take a couple with you home and just fill them out. So do some where you're writing with it next to you while I was looking at it and filling it out, and then try doing some from memory, and then check yourself. Okay, that's how you want to do it. But in order to do that, we actually got to fill in the unit circle. So we're going to start with the degrees. So 0 degrees. What's the next one? 30. What's the next one? Next one. Next one. Next one. 120. Next one. 135. Next one. 150. Next one. Next one. So guys, we already derived this. That was the first thing we did in class today. So if you look at that sheet that we did first thing, it's right there. What's the next one? 225, yeah. Next one. Next one. Next one. Next one. 315, then 330, and then we end with 360. Okay, that's the degrees. Let's do radians. So we start with 0 again. What's the first one? Pi over 6. Next. Pi over 4. Next. It's on that paper, so if you have it in front of you, it's an easy reference. Pi over 3. The first paper we did at the beginning of class. Pi over 2. Then 2 pi over 3. Then pi. Then 4 pi over 3. Then 3 pi over 2. Then finally 2 pi. And then the last part of the unit circle is the points. So what's the first point here? 1, 0. Then square root 3 over 2 and what's 1/2? Then good. Then square root 3 over 2. Yeah. Then 0, 1. Then good. Then good. Then good. Then good. Then yep. Then there you go. And thus your unit circle is completed. So this entire thing you have to memorize. But if you notice, I've given you plenty of places that it's at. If you notice, it's actually on the front of your packets.
What?
It's on the front of your packets.
Oh, wait, no, I found it.
So it's also going to be one of your journal entries. That's why you got the little baby one.
Bro, I gotta write all that on my own.
Oh yeah, and you're gonna be quizzed on it.
Is it open note?
Nope, memory,
Come on now.
timed.
It was open note, we can easily multi
So here's the deal. My recommendation: take a couple of unit circles, like 2 or 3 of them, home with you, and practice filling it in. So do 1 or 2 like with your reference. Do a couple from memory. That's the easiest way to memorize it. It's like a 60-point quiz, and it's an easy 100 if you memorize. Just saying.
I don't see every day, I forget who you are.
Bro.
Well, you're gonna see this every day until the test, pretty much. Now, there's like one little piece that I haven't gotten to yet for 8.3, but we'll do that the first thing tomorrow. Shiki, can you give me that remote right there? Thank you.